Let's do a simple example of a particle that's just moving in the Cartesian coordinates, x, y, z. So it could be moving in any direction, and so its kinetic energy, T, is, let's say it has mass m, right? So 1/2 mv squared, and in terms of the coordinates, we can write x dot squared plus y dot squared plus z dot squared, where dot denotes derivative in time. So that's the kinetic energy of the particle, and let's derive the equations from the Lagrangian formalism. So it's the same thing we've seen before, but we'll look at all the components. So let's say that we have a potential energy, which let's not even specify for now. Let's just see how this works. Is a function of x, y, and z. And so our Lagrangian is t minus u. In this case, that's m over 2, x dot squared, y dot squared, z dot squared, minus this u function. And so what do the Lagrange equations look like? dl by dx dot is mx dot. Similarly for y dot, my dot, and mz dot for that one, and dl by dx is minus derivative of that with respect to x. dl by dy is minus the derivative of the potential energy with respect to y, and dl by dz is minus du by dz. And so when we put together d by dt of dl by d x dot, right, so I'm choosing the x in this case. This needs to be equal to 0. And so we have d by dt of dl by dx dot. dl by dx dot is right here, so take time derivative, we get mx double dot minus dl by dx, so that's plus this, or we can put this to the side and say that it's minus du by dx. All right, so ma equals minus the gradient of the potential energy function, is what we're building up component by component. So if we do this for the other two components, we end up with let's just do it, d by dt, dl by dy dot. Sorry, this should be the Lagrangian or fancy L. d fancy L by dy equals 0. This gives us my double dot equals minus du by dy. And for the last one, replace this with z dot and this with z, we'll end up with mz double dot equals minus du by dz. Right, these are the components of minus the gradient of the potential energy, which is, of course, the force. And so we have the components of ma equals F.